Hello, everyone. It's Jason again from Collaborative Mathematics. This is Challenge 12 in honor of Ada Lovelace Day. We're releasing Challenge 12 on October 13th, and tomorrow, October 14th, is Ada Lovelace Day. This is a day to celebrate the contribution of women in the sciences and technology, engineering, and mathematics. The day is named for Ada Lovelace, who was an English mathematician from the early part of the 19th century, and she's the woman who is credited with being the world's first computer programmer. She worked very closely with a gentleman named Charles Babbage, who was the inventor of the first mechanical computer, but it's Ada Lovelace who wrote the first algorithm, the first detailed procedure that could have been used with Babbage's machine to have that machine perform some meaningful computation. So Ada Lovelace was a pioneer in the field of technology, and Ada Lovelace Day is a day to celebrate the contributions of women in STEM fields of all kinds. When I got to thinking about this new challenge and about women in computing, I thought back to a professor who I had in college named Bonnie John. Bonnie John was a professor at Carnegie Mellon University. I have a bachelor's degree in computer science from CMU, and it was Dr. John who taught me how to program in Lisp. Now, Lisp is a very interesting programming language that you can Google and look up online, but you don't need to know anything about it except this. Because this was my inspiration for this new challenge today. Lisp relies very heavily on parentheses, or brackets if you're from the UK. Just about everything you want to do in Lisp is enclosed in parentheses. And if you want to do complex things, then very often you're taking simple things that are in parentheses and grouping them up inside of parentheses, and then taking those things and grouping them up with other things inside of bigger parentheses. I once wrote a program where the last page was basically all closing parentheses that had been opened on earlier pages, but they all just sort of stacked up there at the end. Anyway, the point is that nested parentheses and legal groupings of parentheses are all really important in Lisp. Now, here's the challenge. Imagine you've got 5 sets of these parentheses. 5 opens, 5 closes, makes 10 symbols in all, right? How many ways are there to arrange these 10 symbols so that you get a legal parenthesization? You know what I mean? How many ways are there that you can arrange the symbols, the 5 opens and 5 closes, so that it works? Like, for example, if I had just 2, I think there are 2 ways to do it if I have 2. Right? I could put them next to each other like this, and then this is a group and that's a group. Or I could nest them inside each other, where this one inside's a group and then it's enclosed by another one. Yeah, I think these are the only 2 ways to do it. This way, it has 4 symbols. It's got 2 opens and 2 closes, but this is not legal. You see, this is fine here, but then this close doesn't close anything. It doesn't have an open to its left. So this is no good. This symbol messes everything up. Do you see? So this is not a legal way if I have 2 pairs, but those are. And I'm pretty sure these are the only 2 ways. And the question for this challenge is, well, what if you've got 5 pairs of parentheses? How many ways are there to write legal parenthesizations like this? So that's the problem for Challenge 12, inspired by the Lisp programming language, which I learned from Bonnie John, just one of the many vibrant women in the history of computer science, a history that goes all the way back to Ada Lovelace, the very first computer programmer. If you'd like to learn more about Ada Lovelace herself or about the Ada Lovelace Day, you can visit them at their website, findingada.com, and you can always find us online at collaborativemathematics.org. And yeah, that's it for Challenge 12. I look forward to seeing what happens next. Have fun.